So you heard about the 10K number of members that we hit. So we do this every other week. So for example, last week we did one on the future of identity. And in August we're going to take a break and start again in September. And probably the first event in September is going to be around women in venture. And so just look out for that. So we have the Hive think tank is an event platform, and this is what you're participating in today. It's also a digital media platform. So look out for our kind of Medium articles. And we have a number of interns at the Hive right now. Can all the interns raise their hands? So there's a whole bunch of them right there behind. And so next week you're going to see articles on what they are doing at the Hive. So we have a number of tracks. Should I be pointing this somewhere? Yeah. So we have a number of tracks in the Hive think tank, and I'm pleased to see our other investors, Verizon, here. So we are planning to get something going around 5G with Mark and Christina and Mara and others. So if you're a corporation and are interested in sponsoring the Hive think tank, please reach out to myself, our CTO, Mohan Reddy, who's behind, or Matty. We are basically doing this with the funding of a number of different sponsors, and so appreciate their support. Just a brief overview of the Hive. The Hive is a venture fund. It's an early stage venture fund. GE happens to be a limited partner. Verizon is a limited partner, and a variety of other financial and corporate entities as well as individuals. We focus exclusively on AI applications and use cases in the enterprise and a few key vertical industries. And you see some of the industries there. We haven't done a whole lot in transportation and logistics. We've funded one company out of the 24 so far, which is really a kind of SLAM system, but very interested in this space. So if you're going to be tweeting today, use the hashtag HiveData so that others can kind of track and follow what you're doing. I'm very excited today to have a very special person here giving the keynote. And after the keynote, we'll bring up a panel. And I think the moderator said he'll accommodate questions while the discussion is going on. So if you do want to ask a question, try to kind of yell out, or we'll try to get a microphone to you. Bonny Simi is the director of JetBlue Ventures. She's the force behind JetBlue Ventures. She's amazing, has an amazing set of accomplishments. She's an active captain today, and which is why I brought my little goggles here. She's won 3 times. She's been in the Olympics 3 times for luge. Did I pronounce that right? And has been for luge and bobsled in the national championships 10 times. She was anchor person at KGO TV, I think, in San Francisco. She has 2 graduate degrees from Stanford, so just an amazing person. So we'll have Bonny come up, and I'm excited to have Bonny here.
So, thank you, everybody. My goodness, what an audience. It's awesome. And to me, what's incredibly exciting is that all of you are here to learn about the future of, right now I put urban mobility. It is urban air mobility, but it's actually a blend. And that's part of the message where I'm saying is, where does ground begin and where does air begin? There's a nice seamless journey here. Now I realize some of you are not aeronautical engineers, are not electrical engineers, may not know much about aviation, may not know much about this topic, but are curious. So for the beginning part of the presentation, I'm going to cover a little bit of how do we get here? What is the basis? what might the future bring? And then, of course, we'll bring up the real experts, where we can dive in deep and you can ask the deep questions. First of all, a little bit about JetBlue Technology Ventures. Oops, you're right. So we launched about 2.5 years ago. We're based actually at an airport. Little tiny factory. We're at San Carlos Airport, where I learned to fly 33 years ago. So I'm coming back home. So what we do, we are the corporate venture arm of JetBlue. We are a separate entity, which allows us to think about far beyond the airline. So when we invest in the intersection of travel and technology, what I mean by that is from the moment a person thinks about travel, and I do say a person, so we aren't getting into non-human travel, which there's a lot of interesting, a lot of drone activity, a lot of logistics, very much on the human transportation. From the moment you think about travel until you come back and say, wow, that was amazing. And we cover an entire broad spectrum. I like to think of it this way too, the mission, and this is a picture. I took it. It's from the captain's seat of the Embraer 190, so I fly the JetBlue's 100-seat aircraft. In fact, I'm headed back to New York and I'll be flying this week. I fly about once a month or so, so if you ever happen to be on the East Coast on a JetBlue aircraft, take a look at, I might be your captain. When we talk about the 30,000-foot view, this is really a 30,000-foot view. Actually, it is the 31,140-foot view. I'm climbing. But this is a very illustrative of how we think at JetBlue Technology Ventures. We want to think, so JetBlue is an airline based in New York, and it's an operating company. And operating companies, it's hard to think of beyond tomorrow, the next day, maybe next month, next year. Oh my goodness, to think about 2020, that is not something normally that an operating company has the opportunity to do, because it's very difficult. You have to worry about, particularly when you're running a safe, on-time operation. So we set up JetBlue Technology Ventures to look beyond the horizon, but being firmly grounded in reality. So that's why we have the augmented reality image. Let me get this slide. Oh, I don't know if the battery's not working. There we are. Just a quick high level, as I mentioned, we cover the entire travel spectrum from the customer side, so this seamless customer journey, which is why I mentioned the concept of urban mobility. I like to think that what customers want is truly seamless from the moment they're leaving their home till they come back, and make it as smooth as possible, an omni-platform, if you will. We also invest in technologies that power a great service and a great enterprise 2.0. Think of call center technology, revenue management technology. One theme that is very relevant to this audience is maintenance and operations. Think about anything, this is more specific to aviation. Think of all the data that's out there, predictive maintenance, how do we predict whether there's going to be delays or not, air traffic control, etc. The revenue side of the business, everything on the revenue side, we're very interested in where blockchain will go as well, and fintech, cryptocurrency, how might that change the world over the next 5 years? And the last one, the one that is near and dear to my heart, I will say I have several members of the team, and each member of my team has different themes. This one is a huge passion of mine, and where's Ajay? Ajay Sharman, I'm the investment principal on my team. He and I work on this one a lot, as well as the maintenance and operations. And Raj Singh, where's Raj? There's Raj. Raj gets the benefit of, he's the managing director, he gets to do all of them. So I get to dive in on the ones I'm passionate about. So regional travel. Why am I saying regional travel? We're an airline that does not a regional airline. So here's the question. If you were on the board of directors of, say, Hilton or Hyatt or Ford or GM 10 years ago, would you have paid attention to what is happening in Silicon Valley? Did you even care that there were things like three guys from Rhode Island coming up with some app that lets some stranger sleep in your couch? That's crazy. Or allowing some stranger in your car? Ow, that stuff doesn't matter. Of course, it matters now. That completely, whether it's Uber and Airbnb, have completely transformed those experiences and dramatically impacted the future of hospitality and ground transportation. So here's one of the questions. If you're on the board of JetBlue, you have to ask yourself, will there be airlines in 50 years? Who knows? Now, our thesis, you'll have to ask me in 50 years if I'm correct. Our thesis is yes, you will still go to San Francisco to fly to New York, or maybe to London. There may be, yes, and for those of you who are into the rock space, perhaps Virgin Galactic will carry you to the, maybe there'll be, maybe Boom will do supersonic travel, etc. But mainstream, even in 50 years, we do believe airlines, as they exist today, will likely still exist. The airplanes will be tweaked here and there. But that's for long haul travel. Our thesis is that from 1,000 miles and less, meaning the regional travel ecosystem, really from 0 to 1,000 miles, will be completely transformed. Think about it. Do you really want to go to San Francisco to go to Santa Barbara? Or what about go to San Francisco Airport to go to San Jose? That does not make any sense whatsoever. But right now, it takes so long on 101 to get from one place to another. And you're certainly not going to drive to Santa Barbara. So this is an area that we're very, very focused on. A couple of quick examples that I thought would be relevant to all of you. So Climacell fits into our maintenance and operations space. Climacell, we met these guys, there were about 4 of them on the team, about 2 years ago, I think. Completely transforming the weather space. And weather, when you think of aviation, when you think of urban air mobility, when you think of data, weather right now, most people go to weather.com or they pull the NASA, government data from NOAA, etc. But it's not very localized. And what these guys do is an Israeli defense Air Force pilot got together and started thinking about what about cell signals? As it turns out that the cell signals between cell towers attenuates differently depending on the type and intensity of precipitation. Think about how many cell towers there are around the world. Think about how many radar sites there are. Think about how many weather stations there are. There are cell towers everywhere. And what these guys are doing is phenomenal. So if you have an interest in this particularly, so they're pulling out data streams, APIs. When I think of Mark, if you don't know about these guys, you need to talk to them. So anyway, Ajay knows a lot about Climacell. Another one that we're very passionate about, as I mentioned, we focus on the regional transportation ecosystem. So what about electrics and electric propulsion? So Zunum is one of our portfolio companies, and what they're focused on is fixed-wing aircraft, which is different than the topic a little bit later today. Fixed-wing aircraft going up to 1,000 miles. Not unlike in the eVTOL space, batteries weren't quite there yet over the last, up until recently. And now battery propulsion is at a point where you can take this, this aircraft here is a little bit larger, but they're 10-seater, which is what they're building out right now, to go up to 500 miles. That's still not yet where we want it to be, but by the time they're ready for the certification, you will be able to fly from San Carlos to Santa Barbara without having to be in a 9-seater, very noisy Pilatus, and you can be in a very quiet aircraft like this. So more to come on Zunum. Those are a couple of our portfolio companies that might be of interest. So now let's talk about urban mobility. In 2018, we're thinking about urban mobility, and if you even go back maybe 3 or 4 years, the conversation was really around ground transportation. So we think of cities and we think about how we're going to get around in the urban mobility. I like to think of history. History does repeat itself. So what was urban mobility like back in the 1800s? Okay? So this is Chicago in 1850. So cars, Carl Benz did the first car, later became Mercedes-Benz, but Carl Benz, 30 years after this. Ford was 50 years. So Chicago, a bustling commerce, large city, was becoming urbanized, going further and further out. Imagine if you lived out here and you worked here and there were no cars, there were no trains. You could walk, there were horses. In the end of the day, the economics didn't work. Yet, why did it spread out so much? Because buildings could only be 5 stories tall. Why? Because the world was thinking on a 2-dimensional plane. You could only be 5 stories tall because people were only going to walk up 5 sets of stairs. And because steel had not been invented yet for building construction, so bricks and stones and wood could only safely go up to 5 stories. Something had to give because the economics of e-commerce demanded that there must be a way to think about things differently. So what was that fundamental invention that changed urban mobility in 1850? You've heard of the elevator pitch, I think. If I can get there we are. The world's first elevator pitch. This was in the year 1854. It was at the New York Exposition, and this was Elvira Otis, from the infamous Otis elevators. Yes, he invented the safety stop for elevators so that you could actually have a safe elevator. And it was elevators that were the big change that allowed us to have skyscrapers. So the first elevator in 1854 by Otis that had the safety stop, and the first skyrise in Chicago in 1857. Suddenly, the world started thinking in a 3-dimensional space. So it's something to think about. What drove that? It drove that was people wanted to get into the center of town. So now we have high-rise and very high, and you're looking down on the ground. Why then is urban mobility all about being on the ground? So right now, unbelievable investments in autonomous vehicles, cars, which is great. Firmly believe that that's the direction that we're going. But the problem with that is we're just going to end up with autonomous vehicle traffic jams. Because there's going to be more demand. Once it's cheaper to ride in cars on the ground, more and more people will be doing it. Yes, there'll be the initial part where you do the carpooling, but ultimately, their roads are only so wide. So we must be thinking about something differently. It is the same story as what happened in 1850 in Chicago. People want to be in downtown, but they can't afford to live in San Francisco. They want to work there, but can't afford to live there. How are they going to get there when the roads, it's going to take them 2 hours to get from South Bay up to San Francisco. So this is the fundamental transformation and change. Distributed, oops, if I can get there we are, distributed electric propulsion. Mark, I know you're smiling. Did you do this slide? You may have. That's 2016 from NASA. The fundamental, so it's batteries. Battery technology, but beyond just the technology, it's the entire system. So if you think back, so this is in 2016, so small, but we're right in this space right now. You can see, and actually we're moving faster than this space. So ultimately, may we get to the fact we have full electric aircraft? I don't know. I'm not sure we're quite there yet in terms of where we think it'll be in 40 years. We do think it's going to be down in this space at least. So that's where, in other words, the Zunums. Now, what's interesting is there are no eVTOLs in this picture. Because when this was done in 2016, I'm going to laugh because, Mark, you probably did it, but I'll let you people can talk to you on the stage. eVTOLs were just really getting going. Now, for some, they had been in people's minds since they were 8 years old, and I'll let you figure out who that would be on the panel. But the battery technology was there, so it was not there. So it was simply a dream. We're now at that place where battery technology is feasible. So if we go back to 2009, think about this. So battery, maybe, 50, the density of 50 watts per liter, at a cost of, $1,000. As we move, you can see how fast the cost is coming down to make it actually efficient, and how well and how quickly the density is going. It'll be interesting to see, again, this one was done in 2016, 2017. It'll be really interesting. I think that the curves are actually moving even faster because of the focus. But it is really only the people in this room, and it's slightly extended. I think in the first gathering, it was the Uber Elevate folks got it going last year. Maybe 500 people, it's about a couple thousand now. People are starting, the conversation is starting. So the mania that is happening in the rest of the world about car autonomy, electric cars and electric autonomy, that began, 8 years ago. That's where we are now. And you're on the absolute ground floor. But how fast is it moving? I would actually argue it's moving faster than what cars did. So I took this this last night. So this is from, if I get the VTOL.org. If you are passionate about this space, I highly encourage you to go to VTOL.org, and then they have a newsletter which you can sign up for, and they keep a running track. Anytime there's a new announcement of some new eVTOL company, they add to it, and it just passed 100. I'm guessing 2 years ago it was 20, maybe 25, and this is how fast. So what is an eVTOL? All right, so electric, E, V is vertical, takeoff and landing. So electric, vertical, and takeoff, landing. Is it a flying car? I cringe when I think of that. There's an element to that, and I'll get to it in a second. I prefer air taxi. There might be other words. I think the panel can have some other points of view on it. There's a lot of different flavors and vanillas of this. So I'm going to give it these. Now these pictures I took from the VTOL.org site. You can go there, and there's 100 of them. I just took a sampling, so I'm not giving out any secrets. These are actually published pictures that are out there. They may or may not be what the vehicles actually look like. I'm just using it illustratively for those of you who might say, hey, that's not really what a Lilium looks like right now. I don't know, I just took it from the site. So think of vectored thrust. There are several different categories of eVTOLs. Vectored thrust. So these are ones that use the thrusters, however the propulsion may be. It could be propellers, it could be thrusters, or whatever. To go lift, so it's to go vertical and forward, so up and forward. So think of it as, it's a cross between a helicopter. In today's world, it's a cross between a helicopter and a plane. So certainly we have some of the large players out there, Airbus, and their Vahana, Bell Air Taxi. Interesting, Rolls-Royce just announced this, I want to say 2 days ago, maybe 3 days ago. So I see the GE folks kind of like, oh, okay. I don't know, maybe GE's got one cooked up and it's just not on the website yet. But when you're seeing, so there's Krim, Lilium, my favorite. Okay, I'll admit, we are an investor in Joby, Joby Aero, so the Joby and JoeBen's on our panel today. So this is, think of lift, cross between an airplane and a helicopter. We, JetBlue, are a company that flies people from point A to point B over distances. And as we start coming in closer and closer, our philosophy is that for the efficiency of batteries, it's good to take off vertically, but as quickly as you can to transition to horizontal flight, because you won't drain the batteries as much, and you can go farther. So this, we believe, is an area where you're going to have the most efficiency in terms of commercialization for air travel for people, which, as I mentioned, is what JetBlue's interested in. Now we'll talk about different thrusters being used for cruise and lift. And there's some names here that you also have heard of. So Kitty Hawk, Quay, they moved down to New Zealand. Interesting, I'll get into that in a second as to why. And it does have implications on the entire industry. Embraer's getting into it. Aurora eVTOL, this is Boeing, so Boeing currently is into it. Then there's some interesting ones, I'll call them the flying cars. I don't know, I hadn't actually heard of these. I pulled them up, but just so this is the area in the space where I think the rest of the world thinks of eVTOLs right now. They think of the flying cars. I don't know, this would be kind of cool. I'm a seaplane pilot too. I think this one is for landing on water. These are obviously just drawings. Not so sure if they'll where the status of them. But my point is, it's lift plus cruise. And then the last one we'll call wingless. These are truly just the vertical. And you've seen quite a bit, perhaps. So Volocopter and E-Hang in particular. One of the things, so Kitty Hawk flyer. One of the things you'll notice in these. With the exception of this one, which I had never heard of, but I thought it was interesting, you'll notice that these have very few seats. Perhaps it's one person, maybe two. And again, the challenge is, and this one is the battery power and not transitioning. But it is, if it is one person, it might make it easier. It's a little more to do autonomy, we'll see. So this is another. Now there is a fourth section, which I did not add, which is basically just the personal flying cars. The straight up, ride them like a motorcycle or personal flying cars. I still see that more in the hobby area. It's happening. but it's not as much in terms of interest in terms of large urban mobility. So this kind of gives you a context of what's out there. So we believe that eVTOLs are part of the power of urban mobility for the future. Does that mean it's going to happen? Well, once you see how much is out there, how many companies, very large companies, as well as very smart people in the startups, I'm going to tell you it is happening. So when and what are the hurdles? Certainly within the next 5 years, we're going to see a lot of activity. Is it going to be in 2021 or 2022 or 2025? Hard to say. Certainly by 2025. What are some of the hurdles? Well, the first hurdle that has been overcome and is evolving very quickly is the battery, the distributed electric propulsion. That's happening now. That then means that the vehicles are being built. Again, that's happening. The next hurdle is FAA certification. That is a big hurdle. A lot of nods. However, the FAA has changed and evolved dramatically, believe it or not, over the last 3 years. Regulation has also changed quite a bit. And what's interesting is up until 3 years ago, really up until 2 years ago, but the path started about 3 years ago, if you wanted to commercially certify an airplane that you could have commercial operations in, it had to be a piston-driven engine, it had to be a turboprop, or it had to be a turbojet. You could not commercially certify a battery or electric aircraft. You couldn't. The rules just didn't, there was no path for it. About 3 years ago, the FAA saw the activity that was happening and created a path. And it's a very interesting and very innovative path. And I know some of the panelists here are very intimate in those details. I will say it is happening. I absolutely do believe that the FAA will not be the hurdle that we thought they would be over time. It might take a little slower than some would like, but that's a hurdle that I believe is well being knocked down. What are some of the other hurdles? The next one is one that I'm very, very close, near and dear to, and I had a long conversation when I first met JoeBen. It's about pilots. You've been reading the paper, I think it was even over that. You know that airlines are suffering a pilot shortage. There are regional airlines now that are shutting down because there aren't enough pilots. So, how is it even possible to think about, if we already have a shortage now of several thousand pilots for commercial, how can we add to that, add 10, 20, 30,000 more pilots? Well, actually what's very interesting is I believe the eVTOLs, given the way, because of the way that the flight controls are set up, because of the autonomy, because of the fly-by-wire systems and how fast they can operate, much faster and safer than humans. Mind you, there will still be humans in the aircraft for quite some time. But the training time drops dramatically, and the training cost drops dramatically. So actually, eVTOLs will be the path to help solve some of the pilot crisis. So I think that's a hurdle. It still has to be mapped out, but that's a hurdle that I believe we will pass. What are two other hurdles I have not seen a ton of activity in yet, and must still occur? Well, the first is, if you think about Teslas, and I know a lot of the early naysayers about Teslas said, yeah, Tesla will actually create an amazing car. So Elon will come up with a fabulous car. But what good is a car if you can only drive it in a few places and you don't have places to charge it? Infrastructure. Infrastructure is a significant challenge that needs to be overcome. So that's partnering with real estate, that's partnering with governments, changing the way, some cities have, let's look at San Francisco. There's something like 28 heliports there, only one in operation. You're going to need even more than that. So thinking about the infrastructure. And, oh, by the way, it's not just the top of a building. That's great. Maybe we can get those 28 heliports working. How do you get the electric power up to the top of the building to charge? Think about the demand of electric. So that is an area. For those who are interested in that space, I highly encourage some innovation to occur. The next and last one that I believe is a big challenge, well, I should say there's two of them. One is being addressed and one that may not be. One is the autonomy. Will there be pilotless? The EHang one, yes, perhaps outside of the US. For regulatory reasons and perhaps for social acceptance reasons, I believe that autonomy will be ready far before we will be ready to actually put it in operation. So I think it'll be quite some time before there will be fully autonomous. It's actually easier to do autonomous airplanes or aircraft vehicles, I should say, than it is cars. A lot less. You're not going to have a deer or a person or anything run in front of you, except on a runway. So that is, there is I call it the coyote challenge. I gotta tell you how many times I'll be taking off on a runway and a coyote or a deer or something will run across the runway. So there is some element of that. But once you get in the air, it's not as much of a challenge. But the last one, if you, all of you, I believe, have been in U.S. airspace system, you have heard of things called GDP, ground delay programs, air traffic control, bottlenecks. Part of that is because of the system and the way the aircraft go, but part of that is the human communication. So if you add another 10,000 vehicles into the air, let's say if you add 500 of them in LA, are the air traffic controllers going to be able to react fast enough? No. So you have to have the ground-to-air communications and the systems to do the communication system. So that is also an area, airspace management and air traffic control. There's interesting conversations. I know the Uber teams have put a lot of work into it, a lot of other teams. It is an area that, again, some entrepreneurs need to tackle that. So those are the main areas at a very high level. I hope I've given some sense of the space. And with that, I'm going to hand it over to Robbie to introduce our panel where you can really get into the nuts and bolts. So thank you.
What an amazing talk. So we'll do let me get the panelists to come up while we show a video on Uber Elevate. Yep, just go ahead. And so moderating the talk today, the panel discussion is Vijay Reddy from Untitled Chapter. I'll let everyone introduce themselves. Just share.
Awesome. Thanks, Ravi.
Well, we should show the Joby video now, right?
You'd like to see that, wouldn't you?
This guy already have.
All right.
Today I'm creating a professional Wix website for my good friend and personal trainer, Dara Hart. Just go to Wix.com. A video background using
Yes, this is part of the panel discussion responsible
and
for
a
Wix.
title to background.
Ravi, thanks for giving us this opportunity to be on the panel. Bonny, great keynote. And GE Ventures, thanks for hosting us here. It's a great place to have here. Before we get started, I would love to have each of the panelists introduce themselves. This is a very high-profile panel in the sense that a lot of news in the ecosystem is misinformed. So these are the experts in the house here. So we'll try to cover from a very high level of, hey, here's what's the hype, what's the reality, and then maybe dive a little bit deeper into some of the real challenges and real questions. I think we'll reserve the questions for the end, but if there's any question which is very pertinent and you want to bring it out, just raise your hands and we'll be able to answer that. I'll start with Ulrich. Do you want to introduce yourself?
Ladies first, thanks. Ulrich Quay, I run BMW Hive Ventures venture fund. We're investing in mobility, so also urban mobility and mobility in the air. So we have not done any investments yet, but I'm happy to explain why not, and if we might in the future.
JoeBen from Joby Aviation. Been dreaming about the space for a long, long time, and it's fantastic to see it coming to fruition, and everybody's so excited about it.
Maryanna, Saenko. I'm a principal with Khosla Ventures, which is a $1.4 billion early stage venture capital fund, and I focus on robotics and mobility and aerospace.
And I'm Mark Moore. I'm the Director of Vehicle Systems at Uber Elevate. And prior to that, I was at NASA working closely with Joby and developing distributed electric propulsion in NASA flight demonstrators.
And I'm Vijay. I'm an investment partner at Untitled Chapter. We invest between $350 to $500 million a year. A couple of my core focus areas have been AI and autonomous. So we've invested obviously in Joby. We're also looking at investments in many autonomous driving. So we kind of like the marriage of autonomous with aviation. Very excited about the space. Before we get started, so Bonny gave a great overview. I did have a few slides, but so this is the older deck. In the news, you'll see a lot of articles about there's a flying car, you'll see passenger drone, maybe flying taxi and eVTOL. I guess one of the questions to the panelists are, which ones are not true and which ones are? Is flying car the right word for this?
No.
Passenger drone?
Maybe?
Maybe?
Can I, just the one thing on the flying cart, why, right? Just why fly more weight than you need? We're all about efficiency in aerospace, so I'd like my car to drive efficiently and my plane to fly efficiently, and some match between the two is just the worst of both worlds. Personal opinion.
So what about flying taxi? Should we call this a flying taxi or eVTOL? Oh, what do you prefer?
So I unfortunately coined the term eVTOL back in 2008 or 2009, and I much prefer air taxi, but.
Oh, cool. Okay. All right, so we'll call it air taxi for the rest of the.
Well, yeah, we actually have tried to come up with an alternate name because we hate flying cars. And we came up with, I think, about 75 names, which were all equally bad. I think the worst one was like Troubadour, and I'm like, what? So please, someone come up with a better name, because eVTOL is starting to stick, and it's kind of awkward, and flying cars got to go away.
I think eVTOL sounds more like a medicine or something to take, right? So we'll call it air taxi or exactly. So all of us have seen or grown up with the dream of flying cars, right? And whether it's the one you see here from the Jetsons or Back to the Future, I guess the big question is, what is the right form factor? What is the right characteristics of an eVTOL and air taxi which you need? So we'll explore some of the options, and I think Bonny mentioned why some are better than the other, but would love to get a little bit more deeper into what configurations work and what really don't. So we've seen a lot of different kinds of vehicles. There's probably like 100 or more. Some of them are rotor-based, some of them are single-seater, some of them are 4-passenger or 5-passenger vehicles. And again, all these pictures, the disclaimer is they might not be what they really look like, right? So I have to say that. So let's start with this. Between a personal vehicle and a ride share, I'll just go down the path, so quick rapid fire. Do you see the ecosystem develop around ride share, or is it more people owning these for their own personal use?
100% ride share, because they're going to be quite expensive vehicles that need to be well amortized and kept highly productive in high utilization.
Fully agreed.
Agreed.
So if there's no dissent, I think we can just stop it there. Gas or electric? Or we had hybrid discussion there as well, but we'll just split the room between gas and electric.
Electric.
Okay, so I think it's electric all the way.
Electric.
All right.
I think it depends on the mission.
This is for short haul.
For short haul,
yeah.
electric.
All right.
Yes, electric.
So runway or vertical takeoff and landing, and this has been a debate, and I think this goes back to Maryanna's point about you either are a car or an air taxi. You can't be both. Do we agree on that? Because we saw a couple of configurations where they were taking off the runway, like Aeromobile and others.
You said it so well. If you try to combine both capabilities, you end up with the worst of both worlds. Things that fly have to stay really light, really focused on doing that mission very, very well.
Got it. I see everybody nodding, so.
The only thing I'll add to that is that there is some really interesting short runway technology that's coming up and getting some maturity. And if you're going short but not super long, right, this is like maybe 100 miles and you want to have a lot of forward flight speed, maybe short runways.
Okay, I'll come back to that.
We should
That's
have that
interesting.
conversation.
So this is a place where we're actually going to disagree.
Yeah.
Great.
Because I was like the extreme short takeoff
Yeah,
enthusiast.
weren't you the guy?
10 years ago, and Bonnie hit this well, you need to minimize the infrastructure expense.
Yes.
You've got to make that as compact, as low cost, and as accessible and highly distributed as possible. And when you get into the operational complexities of extreme stow and wind directions and overflight of residential neighborhoods or even cities at low altitudes, I don't think that works. You really have to go vertical.
But we do have a lot of small regional airports that are already very, very close to population centers.
They're not close enough to where you want to go.
I don't know, I live here and I have 4 airports within 20 minutes of my house, between Palo Alto and where you guys are based and San Jose.
Between 20 minutes of your house. I mean, if,
Technology?
well, I'm just saying 20 minutes is not, to me, even if you're, I want rooftop to rooftop, right? I don't want to have to like.
It's gonna take me 20 minutes to get to a helipad in Mountain View.
But to me, the piece of this whole equation that's the most exciting to me is we have a $230 trillion asset class, which is real estate, and the profound impact that this is going to have on those real estate values. If you take, there have been a number of examples. I was renting a floor in a building in Shenzhen. They put in access to the subway, and the real estate values doubled. So if you think about that knob as a real estate, I mean, many of us are invested in real estate, but commercial real estate this is just going to have a tsunami effect on that business. And where do you locate these? And whoever gets the first pads in a given area, it's just going to be really fundamentally shift the real estate dynamic.
Finish your sentence. Plus you have all the parking infrastructure that's potentially becoming less important, so you will have people looking for another use case, and the parking infrastructure will, probably most of us agree that this is what we, less of a priority for cities creating parking space, and if you look at how much of that is used today, you will have a lot of opportunities, and this is, I think, is the opportunity and the exciting opportunity of having eVTOLs, that you can really have short distances, you can fly from Menlo Park directly to a place next to your meeting in San Francisco. If that isn't the case, it's not that interesting.
Quick question I'd love, building on this though, is where is the boundary to that? So clearly you're not going to take an eVTOL from San Francisco to New York. So where is the mile boundary? For us, we think of it as 200 miles. I'm curious if you think that's too far, too short. Where do you transition to being a fixed wing?
So I think that it's really about the economics, and with a VTOL you're carrying around a bunch of additional expense and a bunch of additional mass and potentially additional drag. And there's a certain point at which the cost per passenger seat mile is flips, and the utility you get by being able to take off and land vertically is outweighed by the additional cost. And yes, I think you're right. It's somewhere in the few 100-mile range.
And is it also a function of the battery technologies and also the kind of design of the vehicles itself in terms of how much you can carry, how far you can go?
Yes, absolutely, because batteries will only get us about 60 to 80 miles, right, JoeBen? But actually, another really important factor in this is actually trip density. So one of the reasons why Uber is focusing on metro areas, large cities, is because we know we can achieve great trip densities, which gives us great pooling capability, because these vehicles make money when you pool and fill them to high load factors. If you start trying to fly these eVTOL out 100 to 200 miles, the trip density and the fleet required to service that area makes the economics less compelling. So I think inherently you're going to see eVTOL in the urban core, and then you're going to see Zunums and others doing the city connectivity of 100 to 300, maybe even up to 500 miles.
I guess this one we might have some disagreement in terms of piloted versus autonomous, right? I guess it's also a function of time in the next 3 to 5 years versus beyond 5 years. But do you need to make it autonomous to Maryanna, especially in the prep meeting, was does it have to be autonomous to make this economically work, or can we have a pilot in the long term and still be economically viable?
Our view was, basically the thesis around the design of our vehicle was that autonomy wasn't going to be ready by 2020, and therefore the regulatory path for autonomy wasn't going to be ready for 2020, and therefore we should launch piloted. In order for the piloted economics to work, you want 4+ seats.
Yeah, exactly. It's dependent on your vehicle size, right? So if you have a 2-passenger vehicle, one of them should not be a pilot in that sense, because then 50% of your potential payload is somebody you're also paying to fly. And unless it's a really high value passenger and route. And so you have to kind of skew the unit economics to the size of the vehicle. My problem as a roboticist and a controls person is that it's really complicated to build. It's potentially much easier to build an autonomous electric aircraft than it is to build a piloted one that will eventually become autonomous or partially autonomous or integrate with a bunch of systems. So it hurts my heart a little bit to think that we're starting with pilots, even though maybe that's the right path to market.
Yeah, Bonnie said this too, right? You're both right. It's much easier to do a self-flying aircraft than a self-driving car, just because of the clutter and reaction time required in the environment where they're operating. But the certification barrier is huge to flying people without a pilot over a very complex urban environment. And we're convinced that you need to be able to go to the FAA with somewhere between 10 million and 100 million trips to have a statistical basis for the safety of that autonomy before any FAA official is going to be bold enough to accept that basis, and that every single corner case of that software has been wrung out and proven to be safe.
So maybe a slightly devil's advocate approach here, right? In the sense that a lot of the autonomous benefit the eVTOLs or the flying taxis are drafting off is because the autonomous cars are building it with tremendous amount of investments, right? And from the timeline you mentioned, it almost looks like you're trying to leapfrog autonomous cars in terms of getting full autonomy, and you have to bear the brunt of all the R&D which needs to go in. And I'm just questioning if you need to wait for the autonomous cars to get there first before we can start building autonomous planes. Fully 100%. So.
Yeah, that's a great question. Actually, I wrote a paper when I was at NASA exactly comparing self-driving cars to self-flying aircraft that gets into all the differences, because it's a very different kind of autonomy. But I'll just say, we think that self-flying, there'll be a statistical basis for self-flying aircraft by 2027.
I'd love to hear Ulrich's view as well, because they're spending billions, if not more, on autonomous driving vehicles. Are they considering that part of the R&D is also going towards aviation, in which case it justifies a little bit more to spending so much money on that, or is it completely different in terms of how we view autonomy in the sky versus autonomy in the road?
I think the requirements are very different. I don't think they can use a lot of what they learn. Forecast can apply for planes. I've never heard anyone claiming, no, we have figured out cars, let's do planes. So it's their full on working on cars, and it's lots. It's not easy, as we know. Waymo has spent years on it and spent a lot of money, and still there are hiccups. It's not easy, and so in our case, at least, the total focus is on cars. I know they have played with the idea of eVTOLs a couple of years ago actually, and looked into this, and they didn't do it for certain reasons I can't share right now. But right now, there's no focus on it, and I don't think there's any learning effect. I don't know whether you agree, but it's in our case, I don't think that's.
I mean, I think the autonomy for aircraft is, we've been flying autonomous aircraft for a long time, and we can do this autonomously soon. I think it's much more of a societal and regulatory question, and I think, a lot of people say it's 2027, 2030. I'm hoping that it happens in 2024, 2025, but not betting the company on it, betting it on piloted as a launch.
So I completely agree with Ulrich that the training set you use for your Zooks or Waymo or whatever the car is not going to help you fly an aircraft faster. However, I think the huge value in the automotive industry for eVTOLs is that the automotive industry comes with volume, and with volume comes the precipitous fall of component costs. And so the automotive companies decided that they want LiDAR systems and they want cheaper radars and ultrasound systems, and that can only benefit this industry. And so I do think that there is an overlap in the path on autonomy, because basically we're not going to enable a bunch of eVTOLs to fly around until the sensors get cheap enough that enough car companies actually demand them.
Right.
And the last one is fixed wing versus rotors, and I think Bonny showed a few aircraft, and there's a lot of people betting that it's going to be like a quadcopter kind of a thing, flying a drone, and others are betting that it's going to be, you need to have wings for it to fly. I guess this plays for both, or maybe not. I'd love to hear your thoughts about what is the best configuration for urban air travel.
Well, you committed to one, so.
Yeah, I know what JoeBen's answer is, but no, I'd love to get your thoughts on that.
Yeah, I mean, as Bonny said, when you add a wing to an aircraft, the efficiency improves dramatically, and as a result, you get more range, you can get more speed, and the speed drives productivity, which drives the cost per passenger mile. And I think that's one of the things that's maybe not completely intuitive to folks is the really profound effect that higher speeds have on operating costs.
Yeah, so I'm overly opinionated in this area, and I just want to give you a metric. So, like, when you see a quadcopter, that has an aerodynamic efficiency, which we relate to lift-to-drag ratio, and it's about 2. A regular helicopter is about 4 to 5. So quadcopters are half as efficient as helicopters. While if you look at a Joby S4, it's probably got a lift-to-drag ratio of what exactly? Probably around 12 to 16, depending on how fast it's flying. So it is anywhere from 6 to 8 times more efficient than a multi-rotor. And that gives you not just a little bit more speed and range, but tremendous more reach and tremendous more productivity. And again, we'll keep saying this, it all comes back to the economic value and time savings value propositions. And so I see very little place for these multi-rotors unless they're just hopping. Yeah, so let's call them hoppers.
Hoppers are a good name.
They're hoppers.
I guess the question is, there's a lot of investors, a lot of companies building this rotor aircraft, right? Is there a place, literally a place, are there locations in the world where these would make a lot of sense compared to the fixed wing aircraft? Or is there like a distance argument to make for these hoppers?
I absolutely think that there is a market for these. I mean, there's some cities where the average speed is like 3.3 kilometers per hour, right? So a hopper is still, even if you're only flying, 50 miles an hour, you're still a lot better than, or, call it 80 kilometers an hour is drastically better than 3.3 kilometers an hour, right? So I don't think that folks that are building quadcopters are wrong. I just think that the economics are not as exciting.
Well, it's not just the economics are not more exciting, but look, there's a huge barrier to entry, right? And that is certified vehicles, commercial vehicles that are flying people over urban areas. And so the certification cost of these vehicles is high, on the order of $300 to $800 million. So what you want to do is, if you're going to develop and invest in one of these, you really want to make sure it's going to be a robust solution across many markets and achieve high productivity. So I'm still quite negative on the multi-rotors because they won't have as robust of opportunities to pay off that certification cost.
What's their operating and maintenance cost?
This is a great point because, again, it gets down to the economic trade-offs. And so while the Joby aircraft is a bit more complex, these multi-copters are simpler. So, I mean, there's an economic trade-off definitely that needs to take place there.
Since we brought up geography, and by the way, this is I have a different slide deck, but I'm zooming it. There are different locations where A, it might make more sense. B, the governments are more open to testing it out. C, the regulations are very different. I'm just curious to hear a take on where do you think these aircraft will start flying first, or where is the bigger market as well?
So I'll let my panelists comment further here. I think that there's a lot of markets that have a deep need in the space. If anybody's ever sat in traffic in Mexico City or Sao Paulo, you're willing to pay an enormous amount of money just to not be there anymore. So there's a strong market need in a lot of places that are willing to take some of the liability and the risk and honestly the noise constraints that I don't think that the US will deal with first. So I'd be surprised if we see the US as a first market outside of maybe military and emergency services. What I fear as the counter to that, and I'd love the panelists to hear their comments, is aerospace, and in particular aviation, is not a market that is particularly tolerant of accidents. And the moment you have a problem, you have the entire market react, right? So you have helicopters that have flown tens of thousands of hours, and Bonny is commenting, shaking her head, but I fear that if we run headfirst into emerging markets that maybe don't have the same safety and critical standards that we might expect of our aviation services, we will run into other challenges.
I think one of the things I'm most excited about is how aggressively both the FAA and the EASA are leaning in. And EASA is the European Aviation Safety Authority agency, and so they're the FAA counterpart in Europe. Both agencies have said we will not be the rate limiter on how fast this comes to market. We will move as fast as you can move, and so this is a significant improvement in the outlook. They're embracing this, and they want this to happen, both as an overall agency and also as individuals. They're as excited about this as we are, and so I don't see. I think the developed markets can lead in this, and that's something I'm very excited about.
Well, we're committed to that. So we will start operations by the end of 2023 in Dallas and Los Angeles. When are you starting?
2020.
Did he just say that? You heard it here first, folks. Joby is starting in 2020. That's awesome. But we are committed to safety. And we think it is appropriate to start in the United States and take on all the burdens to be able to prove the safest possible operations and not try to take a shortcut in a developing market. I hope it's true too, because all of us have to be committed to a great safety record. Because otherwise, if someone comes in and poisons the well, that's gonna be a real inhibitor to this marketplace development.
Yes, sorry, go ahead.
I have a question about that, and you mentioned earlier that it would take 10 million to 100 million trips to prove the FAA that this thing can fly, right?
No, to prove that it could fly autonomously, to be a self-piloted vehicle. We will start with pilots, just as JoeBen is committed to. So we will have a pilot up front. We may have all the autonomy built in as a background to support and reduced workload for the pilot, but there will be a person in command of that vehicle until the certification barrier is knocked down for an autonomous aircraft capability.
But what about the software grade on those systems?
The software grade, whether it's well, certainly there will have to be an evolution of that software, because the whole idea is, yeah, you build in this autonomy in the background, you figure out where the corner cases are while the pilots are essentially sitting on their hands. Yeah, that's going to have to be an evolving system. Exactly how we do that is to be worked out, but this is, yeah, flight critical software, and that's a real challenge. Software is probably one of the biggest challenges relating to these vehicles. There's a lot of software. These are digital, fly-by-wire systems that are not the simplest of vehicles.
So I hear you, JoeBen and Mark, in terms of how you want the U.S. to be pioneer in the space, right? And but you've seen a lot of announcements with Dubai. Actually, they might have already have it in production, like the EHang, and China being a big player in the space with investments in quite a few of these winged hoppers, right? Do you think that there is a contrarian view to these vehicles being developed outside of the U.S. first before they get into the U.S.? And I'd love to hear Europe's take on this as well, Ulrich, in terms of all the different vehicles coming up in Europe as well, right? There's quite a few of them.
Well, I think there's a certain parallel to autonomous cars. In my view, there's a higher chance that this is going to take off not in the US, but in other countries that allow it, where someone can pound the table and say, I want this city to be car-free with non-autonomous units, and that's not possible in democracies. So I think from the there are some countries where people can introduce that within weeks. Like they decided to just demolish certain areas of the city and remove the people and replace it by something else. And that's a challenge in Europe, and that's a challenge in the US. And I think in this space there's also a chance the same is true here. Regulation is one of the biggest barriers, and one of our reasons why we haven't done an investment. There's a certain uncertainty. You're hoping for 2020, but it could be 2030. So you don't know. And then if someone in those non-democratic countries says, I want this to be introduced by 2020, it could be done. So I think from an investor's perspective, I would particularly be interested in companies that are focusing on launches in countries where this can happen earlier, especially when you have a 10-year horizon for a fund, where you need to have an exit within 10 years, which is a little challenging.
We need to talk about this. So this is really important because the inhibitor in my mind is not the regulations, right? Bonny alluded to the great things that have happened, right? We've gone to a consensus standard in Part 23 for small aircraft instead of prescriptive standards. The FAA is working with Joby and everyone else as well as we could dream of. So the FAA is not the inhibitor. What the inhibitor is that, again, this is really complex software, and whether it's the Kitty Hawk Flyer or the Blackfly little, 500-pound vehicle, the software complexity to achieve a safe system is the same as a 4-passenger Joby S4. So unless those little aircraft or those emergent companies who who are trying to jump into Africa or somewhere else, if they aren't spending hundreds of millions of dollars on this software to get it right, then they shouldn't be flying. And I really hope the industry finds a way to protect its future by not letting crazy things happen in emerging markets. Do you disagree?
I don't disagree, but I don't know how you stop things from happening in emerging markets, right? Like I can't tell, I can't go to the Royal Princes and say, please don't buy however many e-hangs or whatever. Actually, e-hang is an interesting company in its own right, but one, I don't know how we stop emerging markets, and they are moving very quickly, so whether or not we like it, we have to deal with it. And two, it's an interesting proposition to consider, which is how much it costs to build the deterministic control systems as opposed to how much it costs to certify them. Right, there's development cost and then there's certification cost, and the certification cost is what might drive up the price astronomically in developed countries as opposed to in emerging markets.
But it also gives you an assurance of safety that otherwise wouldn't be there.
I agree, and that's why I fly, JetBlue and the airlines. Right? I'm from Eastern Europe. There's a lot of airlines I don't fly, and aircraft as well.
So I think since we're talking about government and so on, briefly want to talk about defense, right? In terms of, do you have any thoughts about, and we're all talking about commercial here, how the governments view this space as, because I've heard stories about how this could be a key strategic defense benefit, because you could just fly an aircraft into enemy territory without unmanned, right? So is there, are you concerned about that, or you see there's an opportunity to go after those markets? Any thoughts?
The only comment I'll say here is that if I was ARPA-E or any of these organizations, I would be knocking down your door and Airbus's door and everybody else's, because this would be an obvious need. The challenge for an investor like me becomes, we don't fund weapons systems, and transport is somewhere on that line. And so this is always the challenge, which is you could probably push faster and maybe go further down the autonomy line in a military market, and there's some very lucrative contracts there. But I don't know where BMW iVentures sits, but it's not a comment on the fund one way or another, right? There's plenty of funds that fund military technology to great benefit both the societies and their wallets. I work for a fund that we have constraints and we have LPs where we've agreed not to do that, and so I think that there's a phenomenal market there. I can't participate in it.
So actually, this is a really interesting question too, because this may be one way that there is an inhibitor for these evolving other markets, and that is these autonomous flight control systems are ITAR. So if you're a U.S. company, it is.
Can you explain what ITAR is?
ITAR means
Please do.
export control.
Yeah, so the United States government controls the export of those flight control systems, even if they're for small UAVs, so that they can't go to other countries. And so, at least for U.S. companies, there could be a block towards these emerging markets. Cool. Actually, JoeBen, we started together. So JoeBen and I believe, and correct me if we were the first two zealots for distributed electric propulsion 10 years ago who knew this was going to happen. And it's funny because the way we started and the way we were funded was some three-letter agency gave us some money to work together.
So switching gears a little bit, I think we talked about infrastructure in terms of what are the requirements needed for this ecosystem to evolve, and how do we as all the different players in this space come together to build the right infrastructure, right? I think, so what kind of infrastructure is actually needed, and how can all the different partners participate, not just the aviation people or the autonomous vehicle people, but real estate and cities. So I'm just curious to hear about what are the big
topics to talk about.
Again, this is an area that I'm incredibly excited about, and I also think it's a massive opportunity for cities. If you think about cities are really competing against one another for people, and one of the detractors for a city is traffic. In the .com boom in the late '90s, people are like, I'm leaving the Bay Area. The traffic's horrible. I can't stand it here anymore, and I'm out. And you start to hear some of that again as traffic gets thicker and house prices go up. House prices are driven by mobility, right? People in places, if there's not enough housing close to where you're working, you have to go further away, right? So that's the real estate cost and the transport cost. So if we can provide people with a better means of getting around, it fixes the real estate problem and their commuting problem. So and cities spend huge amounts of money and can't get anywhere in terms of expanding ground infrastructure. We spend trillions of dollars a year on ground infrastructure, and we still are stuck in traffic.
Maybe talking about infrastructure, from an investor's perspective, one of the uncertainties that we saw is that you don't really know how cities react to it, whether they're really welcoming and set up hundreds of helipads all over the city, or whether they limit this to a handful or 10 or 20, nobody knows. Right now they are all singing the song, we want this to happen. And when the first complaints are coming in, because there is some noise, it's not, without any noise, right? So, you don't, you put yourself in the hands of some guys who maybe, as we see these days, difficult to control, and don't always take the best decisions, right? So there was one, just from an investor's perspective, one uncertainty I had when we've been looking at the sector. Unpredictability of are they really as open as some of them seem to be, or do the first guys, as soon as the first complaints come in, treat those helipads in the same way as they treat the helicopter landing spots, which are really limited. If you look at New York, it's scary how few spots you have, and this is going to change dramatically just because it's electric. Maybe not.
So if I'm buying a house, I live in South Bay, and a lot of places to work are in Palo Alto or Los Altos, right? And these houses are incredibly expensive. So 2023, 2025 is not that far off, right? I could be living in Sacramento and be working and commuting, or I could be living in another place where the houses cost half as much. Do you see that the entire housing markets and the way we work and the way we commute is going to be radically changed in the next decade, let's say?
The terrible answer is maybe, and we think about this a lot, right? As we think about, like at Khosla, we think about not just how you're traveling to where you're living, but what those buildings are made of and how they're powered and the rest of it. So if you look at these systems holistically, and then you look back historically, what you realize is that basically what we have, our fantastic ability as humans, is that we're incredibly adaptive. Subsequently, we will adapt to the same constraints that we always cause ourselves. So on average, and this doesn't sound appropriate for most of us living here, but an average commute in the US is about 30 minutes. And what you find is people just expand and expand and expand until they get back to that average, slightly miserable commute. And in the Bay Area, it's about an hour. In New York and New England, it's about an hour. So my fear is that for some period of time, maybe housing will become more affordable, maybe some of these systems will slack, and then they'll just get dense enough that we get back to the same level of mild misery, air traffic control, and the rest of it. So I think everything's a little bit like adding a lane to the highway, right? To Bonnie's control is that even if we go in the vertical axis and we expand up the Z, I'm not sure how far we get before we get to the same problems.
It's at 30 minutes, I could live in Santa Cruz now.
Yeah, like,
Yeah.
You're right, like it's not bad.
And you get over the geographic barriers, right? That mountain that causes that horrible Highway 17, right? Yeah, that's gone, right? And bridges, the bay, that barrier's gone. But I do want to comment on this, about this really happening in 10 years and the infrastructure question, because this is why, even though JoeBen and I are best friends, hopefully still at the end of this panel, we went our own ways. And because to me, I realized it is not all about the vehicle. And JoeBen is developing an awesome vehicle. But there's so much more that has to happen. And it is the vision that Uber has shared, that this is all about developing a whole ecosystem, that we've got to get the infrastructure in place, we've got to get the airspace management and network in space, we've got to get the comms in place. There's just all these different layers, and no single company is going to do it on their own. We have to do this together. We have to build a collaborative ecosystem that realizes this is a $3 to $10 billion investment, but the returns are enormous, and it's worth making, and it's worth doing together.
Sorry, going back to your question, basically, the commute piece which you talked about was, one is obviously flying taxis, and, sorry, the term whichever you want to use.
A lot of questions, but I give you my.
Sorry, how does, if the full self-driving capability comes in, or the full fleet management, autonomous fleets comes in, that compared to the need for me to fly for 30 minutes versus having a swarm of, autonomous driving cars taking me to that place? Why is there then a need? I understand 50 miles or 100 miles, whatever the mile is. How does that work?
Sorry, long question.
I have a short answer to it. I think we will always convert back to hypermodal transit in the sense that you don't just use one mode of transit, right? And that's why you've seen this massive boom of electric scooters in San Francisco. It's not because people love scooters, it's because people have to travel a mile, and there's a better and a more efficient way to travel a mile. And so I think what we enable more modes of transit is for each mode of transit to act in its most efficient and cost-effective way for its passengers. What I think this actually changes for our communities is better physical mobility enables better economic mobility. So if you lower the cost per passenger mile, regardless of the mode of transit, for more people get to live where they want, travel where they want, and ideally rising tide for our communities.
Yeah, so let me just answer your question directly around, is this going to have a profound effect in, I think you said 2030. If, my mission is to save 1 billion people an hour a day, and 1 billion people, if 100 people can, if one aircraft can serve 100 people over the day, that's still 10 million vehicles. Getting from making, ones of vehicles to making hundreds of vehicles to making tens of thousands of vehicles to making millions of vehicles is, each of those is factors of hundreds of increases, and there's a bunch of them. And so it will take, to build a manufacturing system that can build millions of these aircraft. Most aircraft are built in quantities of hundreds today, right? And so this will take time before we're having a really profound global impact. It is going to, yes, we will have a significant impact in a single geography with hundreds of aircraft, or we will start to have an impact with hundreds of aircraft in a city like LA, but until we have thousands of aircraft, it becomes, that's when it actually begins to make a meaningful difference for a lot of people.
So let's dig a little bit into the numbers. Sorry, Glenn.
Can I answer this question more directly? Because, look, Bonnie's talked about this too, right? I mean, self-driving cars, I'm convinced are going to happen. Don't know exactly when, but when they do, right now you're paying about $2 a mile for Uber. When they go self-driving, that cost plummets. And guess what happens to supply and demand curves when the costs plummet? You get a lot more demand. And so, but those arteries on the ground aren't changing. So they will be congested, and we need new options, especially for high productivity, rapid travel. So your lifespan is limited. We all need to realize that, and you're going to want to be as productive as possible. So if you can get around at 200 miles per hour versus 25 miles per hour, there's a good chance that many trips you're going to choose to do that, especially on the longer ones.
So I was coming back to the same question, so one second. So you mentioned $2 a mile on Uber, right? What is the consensus estimate on how much it would cost per mile on eVTOL? when in production?
So we've actually
In the ballpark, so.
we've shared those numbers at our summit.
You have the numbers to second digit, so.
Yeah, so we think from our economic analysis, and we've spent a lot of effort on it, we're convinced that we can be competitive with what Ubers are on the ground today. And the magic for that is that each eVTOL in the air is 20 times more productive than an UberX on the ground. So if we can pool them and keep high load factors, which is what JetBlue and every airline cares about because that's how you make money, keep these vehicles productive so that they're turning around and constantly being utilized like 2,000 hours per year. Again, JetBlue is probably at 3,500, maybe even 4,000 hours per year. A standard helicopter today is like 150 to 300 hours per year. These are expensive assets. You gotta keep them making money. So you do those things, and yeah, we think we can compete with UberX pricing today.
So Ulrich, if I can get to San Jose to San Francisco, $20, either an Uber or a flying taxi, right? How do you view the competition from autonomous vehicles versus the vehicles in the sky?
Well, first of all, there are some ifs in your sentence. That's good. Good news. But of course, the things are changing a lot, and I don't think anyone has figured out how the future world looks like. I think everyone is well advised to spend a lot of money and be in the center of that and not watching it and not being part of that. So as an OEM, I think right now is, they are all keen on continuing the current business model as long as it lasts. Last year BMW made $10 billion. That's, you can save a little bit of that and add it on annually. And then work on being prepared for the future. That everyone has to figure out which role he has, and I think autonomous driving and flying goes hand in hand. It's helipad, even though there may be a number of them, will not be next door, right? And so there will be ground transportation, especially for shorter distances, and for longer distances. I see there's also, for some at least, they will have the chance to fly as well, but it will not be the majority of the population. It will be, maybe that's the premium mobility of the future, and which will always be a part of the journey, and the part of the journey will be ground transportation.
Yes.
Sorry, go ahead.
We need a microphone.
My name is Geert van Warmerdie. I'm heading up Shell Ventures. I'd like to talk a little bit about batteries and get real about it, because I like eVTOLs and I'm going to be your first customer, and we are in electricity and in fuels, as you know, and we have to sell you more electrons. Why the hell are you going electric? It makes no sense whatsoever. And I'll tell you why. I mean, the energy density per liter that the nice lady from BlueJet presented is seriously underwhelming. I mean, you're looking at an energy density per liter that is 40 times less than kerosene. And you could go biokerosene and avoid the carbon footprint debate, of course. And if you look at it per kilogram, it's even worse, because lithium ion is a lot heavier than kerosene. So why are you obsessed with batteries? Because it limits your range, and especially if you go autonomous, the compute power you need, it's stupid, right? So explain this to me. And I wanted to, provoke a little bit for the purpose of having a good conversation.
That's a great conversation. I think Bonny will say Zuna Mayo is an answer for that, but I'd love to hear JoeBen and Marco.
For me, it's all about noise and operating cost. So when I tried to do this 25 years ago with combustion engines, I realized that the noise you weren't going to have a ubiquitous mode of transportation. With a combustion engine, a high specific power combustion engine are ridiculously loud. And so electric is what really makes that fundamentally possible. Unfortunately, 25 years ago, batteries were we were running nickel metal hydride batteries at 50 watt-hours per kilogram, and you couldn't close. The projections were within 20 years we were going to be at 200 watt-hours per kilogram, and with that you could actually make a useful VTOL. And so that's the reason that I came back to the space, and that we've been able to actually make this close. And again, the other piece is the maintenance cost. Maintenance cost is really, really crucial to making the economics of these aircraft close, and the maintenance cost of overhauling a $100,000 or $200,000 turbine is is really challenging, or a piston engine. So for me, it's noise and maintenance cost, and operating, which drives operating cost.
So I've run this analysis backwards and forwards as an external market perspective, right? Because I don't have a stake one way or another in this game. I just want to find the solution that is likely to work. I've never arrived at a number that makes the operating cost for a gas or a diesel or a hybrid system look remotely reasonable in terms of long-term cost per passenger mile.
So I'll give a simpler answer, and that is because we can. It doesn't matter that it's 40 times worse than fuel, because we're only going a maximum distance of 60 miles. What matters is that we can rapidly charge those batteries to get a fast turnaround. So the challenge, as long as we get to around 250 to 300 watt-hours per kilogram on the battery, which is very much within reach, then why not do that? Because the economics are so much better with that all-electric solution than, you know, putting on a series hybrid. And so what we really need to watch is not the specific energy, right? It is on track to meet the range that we need. The thing to watch is, are those batteries going to be able to get, you know, 25% capacity increase in 5 minutes? Because we got to turn these aircraft around. And are they able to charge 75% in 15 minutes? Because if they can't do that, then you're right, batteries are a real problem for achieving high productivity.
Especially since fast charging has a terrible impact on the
Fast charging today has a terrible impact on cycle life, which has a horrible cost, because these batteries are expensive, right? And you've got to amortize them well. That is a big change that happened, and it's not just about us. Guess who cares about fast charging as much as we do? BMW. And the rest of the entire automotive world. And there are great chemistry changes that are taking place to provide that solution.
I'm gonna add one point too. I mean, airlines, we have lots of experience in operating and what are direct operating costs. You know what the top 3 costs are for airlines? Labor. Eventually, there's going to be pilotless eVTOLs. Fuel and maintenance. So if you eliminate or reduce the cost of all 3 of those, you have an extraordinarily economical transportation mode.
That's the key.
So one of the hidden things that we saw on the HUD earlier is the tailwind. I was interested to know, what are the tailwinds in your industry? What motivates the entire industry to go forward? Because all of you guys are within urban cities where usually airplanes are between cities, and except for little comments on Bonny's slide, we haven't heard anything about that. What are the drivers?
For me, it's all about time. If I can save you an hour a day, that really is a meaningful positive impact in your life, and so that's what I'm motivated and driven by, saving you time.
I guess it's not just about competing with cars on the ground, right? If you're going between city A to city B, which is even like an hour or half an hour flight, you can skip that with aviation. You can also cranes, right? I mean, you're going to disrupt a lot of different markets. I think starting with helicopters, right? I think there's different transportation markets that potentially short-haul flights can disrupt.
I think the tailwind is also energy density, right? If we can make a strong argument for why they need to be electric, then you make a strong argument for why there's value in short hop flights, and then you say that the medium and longer range stuff will come eventually, but it has to follow the trends and the demand curves.
So to me, the value proposition is definitely time savings, but as you really get into it, it's not just how much time you save, but how certain you are for when you will arrive. Because people build in buffers like crazy because there's high uncertainty with that ground traffic. We are going to have far lower uncertainty in this air nodal system And that is another huge part of saving time, but also ensuring that there's high certainty in when you can get there.
So I'll play devil's advocate before opening up the Q&A. So I have a few quotes here. One from Elon Musk, who's afraid of hubcaps falling up from the sky. Also, one from Peter Thiel, and even Henry Ford. I think when back in the 1940, we had a lot of false starts. Some people might argue, hey, look, is this one more false start, right? I guess the question is, how do we convince ourselves this time it's for real?
So actually, I lived through the airjet, bubble in the 2000s, where Dayjet and all these very light jets were saying, oh, there's going to be this regional market, and the problem is they had no technology change, right? They were trying to create a whole new market with no new technologies, and so they ended up flying these Eclipse 500 aircraft at 18,000 feet, guzzling fuel, with 2 pilots flying around an average load factor of 1.4 people. That is insane, right? The economics are clearly never going to work out. Especially this aircraft was designed to cruise at 40,000 feet efficiently. So it's like nothing was enabling them to have a great economic basis for the solution. For us, there's huge technology enablers, but not just technology enablers, business case enablers, right? I mean, if we tried to do this 5 years ago or 10 years ago without Uber, this would make no sense, right? Because we're not getting you all the way to your door. We're getting you to the closest, vertiport to your house. And if you don't have a car sitting there waiting for you and you have to wait 20 minutes for a taxi, this whole solution falls apart because it's a multimodal transportation solution. So it's as much dependent on the last 5 years of revolutions that have happened in ride sharing and the business models as it is in the vehicle technologies and airspace management technologies. So you're welcome.
So maybe I'll answer for this panel. I think it's for the first time, it's the culmination of many different things, right? I think one is battery technology getting better thanks to autonomous vehicle companies and the automotive companies. It's the combination of rideshare. If you don't have enough passengers on a vehicle, this doesn't make economic sense. And it's the aircraft manufacturers with whether it's distributed electric propulsion or the advances in terms of the software which is needed. And also it's the funding. I think it's unprecedented in terms of how much funding has gone in. So I think as a combination of all the different factors, this is the first time all of these have come together. I think the question for all of us is it takes a village to get this off the ground. It's not just one segment, it's a lot. It needs participation from NASA, it needs participation from FAA, the governments, GE and Siemens, and I think we're extremely excited and hopeful about this. So I'll open it up to Q&A. How much time do we have?
Wow.
10 minutes. I'll leave like last 2 minutes for the closing comments from the panelists, but Q&A.
Hi everyone. I love this conversation. The first thought that I had was, okay, so we have traffic on the ground for all the reasons you guys stated. Who is working with the FFA to come up with software that's going to manage the traffic in the air? Because I'm just thinking, and the other thing is, you want to make this accessible to not just the elite. I'm guessing, we want this to be more equal opportunity. So therefore, at some point, scale, volume, you're going to reach the same commute problems that we have now, and any mistakes in air are magnified because, let's say, you have different planes flying at different altitudes. If something happens up here, it's a domino effect that's going to maybe cause accidents, at other altitudes.
For a change, I have an answer to that. In case you haven't heard of a company called AirOS, which GE just launched about a month ago, that is essentially what AirOS does. Is essentially the ways, if you will, for all the drones and all the things which are manned or unmanned, which will be flying around and as they take off. So we're going to be, you'll be downloading that app very soon, hopefully, if you believe the panel. Sorry, didn't mean to interrupt.
Thank you so much for the vision of the future. It's exciting. Bird farm with Infinivare building fault-tolerant power systems. Knowing how difficult it is to get into critical systems, what do you think the market adoption rate will be when it touches human lives? Because Facebook pulled the project out, the solar project, overrun, budget overrun, and they're not in the business bringing up things. Solar Impulse had batteries, stranded them in Hawaii, good place to get stranded. We can't keep laptops out of fire with lithium batteries. And by the way, I like that comment, 34x, 34 megajoules per liter for gas, 5 for Fiskars, twice as efficient solid state battery. And we still haven't figured out how many megawatts it takes to charge them in 10 minutes. A lot of issues there, but safety first. How do you overcome the hurdle?
Aggressive testing. Right, I mean, we're working on standards, like the industry is working on standards to make batteries safer to fly. At some point, someone will convince Panasonic, which makes phenomenal batteries, to allow them to let Panasonic feel comfortable flying them, and that, you know, you do drop tests and fire tests and puncture tests, and you get comfortable and you build the statistical data set. And it's the same way we make any other safety critical system. It's an enormous amount of work and money. And time.
Yeah, so I mean, I love the strategy that Uber has implemented, because again, are we building a vehicle? No, but we're a Silicon Valley company, and often Silicon Valley companies can get this arrogance to them, right? That they can do everything, right? Facebook is developing solar planes. Wow, well, I worked on solar planes for 10 years, and that's a really hard hardware problem. Facebook really shouldn't be doing that. So, sorry, Facebook guys. Look, our strategy is, I mean, we're not doing vehicles. Instead, we're partnering with Embraer, who, you fly them, Bonny. They're some of the best small jets on the planet. And guess what? They know how to design for ultra-low operating costs and ultra-high safety. Who's one of our other vehicle partners? Bonny, through Aurora, right? So, I mean, these are major companies that know how to develop ultra-safe flight system, level A software, and can do it right. And that's no knock to Joby, because everything I've seen, even from a Silicon Valley company, because we are too, so I can't knock them too hard, but they are doing incredible work. But I mean, these are very expensive, complex systems that are going to be carrying around living people, and it's going to take hundreds of millions of dollars to rigorously test them and prove them safe. And guess what? Joby's committed to that. We're committed to that. And our vehicle partners are committed to that.
I would also say one of the things that is so amazing about electric is, you know, we talked about maintenance cost, but it also is about reliability, and reliability drives safety. And also with distributed electric propulsion, you can build an aircraft that has 0 single points of failure. So most of the aircraft, small aircraft that you fly on today have hundreds of single points of failure. And so I think at the core of what we're talking about is about safety, and the aircraft that we're all conceiving are really fundamentally better because they are safer. And it's, you know, airlines, JetBlue and the rest of the airlines actually are so, they're 5 orders of magnitude safer than the driving per passenger mile, right? So some of us think about airplanes as dangerous. We all sensationalize the headlines around airplane accidents, but as a transportation system, it's by far the safest transportation system we have. Again, by many, many orders of magnitude. So that's something I think that the airline industry can be incredibly proud of. But we also, as a new emerging industry, need to take very, very seriously, and we need this to be safer than the mode of transport that we're replacing, which is ground transportation.
I work at Boeing, so obviously we're a flight scientist with Uber, a partner. JoeBen, I'm curious if you feel comfortable. We've been talking about a little bit of your strategy of working independently outside of some of these networks?
We are constantly in conversations with different ride-sharing companies around the world, including Uber, and we think that space is going to evolve as these autonomous ground vehicles come into play, and we will continue to be open to opportunities.
Ready to shake on it?
Louis Philippe, I've invested in this industry, a company called H55, which is the technology behind solar impulse. So I think the panel unanimously voted for rideshare versus the personal model. Uber famously built the largest taxi service in the world without owning a single taxi. I'm just curious, on the panel, who will own these and who will operate them?
We see these as incredibly valuable assets that make incredible returns, and we don't see there being a shortage of people who would like to own them and operate them.
So we've actively been engaging with the aircraft leasing community. They are very, very interested and will be great partners in this. And if you look at, again, JetBlue or United, guess what? At least 40% of their aircraft are owned by leasing companies, not by the airlines themselves. So I see this industry evolving very, very much to be commercial aviation and to utilize a lot of the lessons learned that they put in practice over a 50-year period to get to incredible low cost. I mean, you can fly across the country for a couple $100, and it is 100 times safer than driving on the ground. To leverage that industry is something we must do to get this right.
Yeah, I'm just curious, you want to have this to be a ubiquitous mode of transportation anytime, anywhere, but there seems to be a limiting factor that hasn't been really addressed here, which is weather. You know, especially for small weight vehicles, you know, as a pilot, you know, you have a thing called operating, speed for the type of weather you encounter and the loads you're going to encounter. You want to be tossed around, whether it's, rain, a thunderstorm, or anything would be, and, you address that.
Yeah, I mean, that's been part of our analysis to understand how many days are VFR, flying days, and to build that into the economic model. But these aircraft have really robust control. They have a lot of power that gives them control all the way down to the hover. And sure, we won't fly in thunderstorms, but if you look at Dallas or Los Angeles, we're going to be flying a very high percentage of the days.
I think one of the really exciting things that VTOL gives you is the ability to reduce the size of the wing, and what that does is it gives you a user experience that's much more akin to flying in a jet than to flying in a small airplane. The light wing loadings in small airplanes do result in a bumpy ride in turbulent conditions, but commercial jets are a substantial improvement there due to their higher wing loading.
Let's take maybe 3 questions.
Michael Ludick of Knowledge Investments. My question is why so few actually passenger helicopters here in the Bay Area comparing to many other places in the world? I mean, today.
Noise. No, it's noise restrictions.
So Khosla, is noise one of the top 3 factors for limiting mobility in the US?
There are helicopter operators who here in the U.S. will say that noise is not just the top constraint on their business, but the top 10 constraints on their business.
Thank you for the panel. I have a 2-part question. What is the estimated price for a ride from here to San Francisco, or from a rooftop to rooftop from one part of New York to another part of New York?
So say it's 25 miles, if it starts at the cost of an UberX, maybe that's $75. Over time, if that comes down to a few tens of cents per mile, it's call it $5 or $10, right? So that's, and at that point, it takes a long time to get to the point where where demand isn't so high that you can match that price, right?
Before getting autonomous? Before being autonomous?
You can't hit those prices without autonomy.
So we're convinced that the demand will be substantially higher. So even if we could be profitable at an UberX price, you always are going to try to match the demand and supply curves, right? And the vehicles will be the constraint on the system. So in the beginning, just like any technology, it'll be a bit more expensive. And over time, as that evolves into a more mainstream market with larger fleets and more aircraft available, it will get less and less expensive. But I think, as we have talked, we've done completely independent economic analysis along with other companies, and there is a robustness to the economic model that we're seeing across all the participants.
So we did an independent analysis as well as part of the investment. So it costs a few $100s to go from Hamptons to, let's say, New York on a blade, let's say. Between that point and the price curve to like a couple of bucks a mile, you can easily imagine getting there cheaper, faster, more painlessly than the existing mode of transportation. So, yeah, exactly.
Maybe last question?
Last question, no pressure.
So, I'll make it good. First of all, thanks. It's been a great panel, a great discussion. Thanks for everybody involved. I think I just heard Mark say that VFR is an operating constraint. Is that true? And does everybody in the panel agree with that?
This is an awesome question.
Thank you.
Yeah, so we will be, VFR is visual flight rules. And so there's instrument flight rules or visual flight rules, depending on what type of weather you're flying in and what the conditions are, visibility or otherwise. We will be flying visual flight rules all the way until we get to self-piloting. And then we don't see ever going into IFR. IFR has a lot of restrictions and embedded costs and complexities to it. We are already working with organizations to start defining what we call autonomous flight rules as a new category. And it's going to take time for the FAA to embrace this. But we see starting this market in the first few years with visual flight rule operations and then turning into autonomous flight rules, which can have be in closer similarity to IFR, but with much less cumbersome factors. Does anyone else want to comment?
We're definitely driving towards IFR.
So I'll add one quick comment to it too. Remember I mentioned one of the big challenges out there is pilots. And everybody's agreed, these are all going to deploy with pilots. But there's a pilot shortage. One of the reasons that there's a major pilot shortage right now is because of some changes in the regulations that require pilots to have 1,500 hours. And for pilots to get that to fly in commercial operations, it's very expensive and very difficult. What is interesting in these rules of IFR versus VFR is that in existing regulations, pilots can fly in commercial operations at 500 hours in the type of operations that air taxis would be. So when I say that this could actually help solve the pilot challenge, that's my point. And because of advanced avionics, but also in the fly-by-wire, the aircraft are very, very easy to fly. So I've flown in the Joby simulator, and I won't say, well, Bonny, you've flown, you got all these hours, that's cheating. Ajay got into the simulator, and in 10 minutes of instruction, he was taking off and landing and flying without a problem. So my point is, at 500 hours, by the time you have that pilot flying you, they're going to be very good, very qualified, and very safe. And that will help solve our pilot challenge.
So, I think in closing, I'd love each of the panelists to just close with the remarks. If you've been following the space either over the last few years, you'd have seen that the space has gone from renegade people like JoeBen and Mark and others in their garage and basements building what they really love to. This is just news this week, right? I mean, you have Aston Martin come out with a vehicle. We saw in Miami they came up with a building which has flying car ready building. And then Boeing started a new division on flying cars, and again, what do you call them? Sorry, yeah, flying taxi. But you can see that people are using flying cars still, BBC and others. So there's a lot of announcements there, and almost every day you see, and there's a lot of noise in the information. But the goal of this panel was to at least cut through some of the BS. So I'd love for each of them to give their thoughts on where this market is going, and any comments?
So I would like to give you my vision of my 2027 commute from Los Altos Hills to San Francisco. I take my M3 at 7:20 to the next vertiport, take one of the VTOLs, maybe Joby, that's run by Uber, invested by Khosla, and then arrive in San Francisco 15 minutes later and take a line scooter, also one of our investments, to my final destination. And I will arrive at 7:50.
I love that vision. And I think it's going to become a reality, and it's going to become a reality much sooner than the world thinks. There's, because of the incredible groundswell of excitement around this space, we're not reliant on one or even 5 companies to make it happen, but there's 100 vehicle makers plus hundreds of other companies in the ecosystem that are all driving to make this happen as quickly as possible. So it is going to happen, and it's going to have a really, really profound and exciting impact on our cities and on our lives. And so that's, I'm very, very excited, and hope all of you guys will join us in this crazy quest.
I await this future, and I guess I'll just comment that when it comes to safety critical systems, I'm much more inclined to trust computers than I am to trust people. So I hope that we have a full court press on the autonomy side, and that we find a reasonably priced path to certifiable autonomy.
So I'll just close with our tagline that you saw at the end of the video, which actually you did our advertising. Closer than you think. This is really happening. It's happening now. It's going to be. We are very privileged to live in these exciting days where we get to be the new Wright brothers. At least some of us.
Yeah, I have a 5-year-old daughter. She doesn't really care for what I do. Ever since I told her I've invested in Joby, she keeps asking the same thing every week. Are we there yet? Are we there yet? Are we there yet? I think we're going to get there sooner than we think. And Intel is committed to a partnership approach in this space. And just like in autonomous, we are going to work with partners to make this happen. So thank you all for coming here. Again, thanks to Ravi and Hive and GE Ventures.
And thank you to Bonny and for an amazing keynote, and Vijay for amazing moderation and this great, amazing panel. Everything you ever wanted to know about flying vehicles. Please join me in giving these folks a applause.
Muss vielleicht gehen,
Ja,
So which so we have some batteries. We have the